What's up, guys? It is Alicia all here, back with day 9 of your 30-day DevOps challenge, where we are combining the NBA API with AWS services to create some great projects that'll help you understand how this ecosystem works. I'm excited about today because we're actually going to be building a game highlight processor. So essentially, we're going to go out and find some highlights. We're going to process them so that way we can actually view those images or those files. So exciting stuff. To accomplish this today, we're going to be using a few services. We're going to be using Docker, S3, of course, for some storage, and then we're going to be using AWS Media Convert. Now, I'll be transparent with you all. When I first built out this solution, I think I made it a lot more complex than it had to be. No, I know I made it a lot more complex than it had to be. We were using AWS ECS, which is like Amazon Container Registry Services, we were using Fargate, we were using MediaConvert. It just felt like it was a lot of components, and I had to really go back to the drawing board and stay true to myself and what this challenge was about. And that's really getting the beginners or the entry-level people out in the field to understand these concepts without feeling overwhelmed and not trying to impress the average guru who's on here. So my apologies for those of you who might feel like this is a bit watered down. I wanted to make sure we were meeting people where they were at. And so when I think about this building a car, right, I feel like what we had the first go around was probably a Ferrari. And I think more so what we need is a Toyota. We just need to understand the bare basics of how to get from point A to point B. And then we can throw on some bells and whistles and some technology to make it better as we digest this information. So let's jump straight into it and share screen. Now, as always, before we get started, be sure to like, comment, and subscribe to this content. After this challenge wraps up, I will be dropping weekly content on this page and you will not want to miss it. And even more importantly, if there are some topics that you don't feel comfortable in, feel free to check the description. I will have some videos linked that explain things more in depth than I care to go in on this forum because I don't want to lose our audience at the same time. So let's jump into it. So first things first, let's do a quick overview of Docker and why is it that we're deciding to focus on this week. If you haven't already gotten that lesson, if you have, feel free to fast forward past this. But essentially, the way that Docker works is you have 3 components to it. You have a Docker file, which we could think about as a recipe, if you will, a list of steps of what Docker needs to do to create something of our interest. And then you have a Docker image. So you take that file and you build it, and it creates a Docker image out there. And then after that image is created, you are then able to run that Docker container itself, right? And so why these are used is you have to think about development in the world that we live in, right? We have multiple operating systems. We have multiple ways that people can access our information, our apps, our data, whatever it is that you're building out, right? And so when you have multiple ways that people can get to the same destination, how do you ensure that no matter what mode of transportation that person is using, they have consistency, they have reliability, and they have scalability without our development teams having to rebuild this thing out several times depending on what our clients are using, right? And so containers are a very lightweight way to solve that industry need. Now, if you know a bit about development, you have also heard of virtual machines. There's a great debate between containers and virtual machines, and I'll save that for another day. But essentially, virtual machines, they take up a lot more resources to achieve these things, and Docker containers are thought about being more lightweight and easier to scale with. And so with that, let's tie it to something tangible that we've actually done before. So that way you don't get bogged down in these technical topics. I like to think about Docker as a portable kitchen, right? You bring your own portable kitchen to bake cakes consistently at any location. So meaning if I went to bake a cake and someone's oven only preheated up to 300 and I needed to bake my cake at 400, it wouldn't even matter because I have my portable kitchen with me, right? That is the same analogy with the operating systems. You use that same recipe, that same Docker file to build a new kitchen setup every time. That ensures I have the right oven, It preheats to the correct temperature. It's able to cook for the direct duration of time that I need my cake to bake for, etc. Hopefully you guys have been able to tie that in, right? So Amazon S3, we talked about this last week a bit, but I'll go over it a little bit just in case you are not going through this asynchronously at the moment. Amazon S3, we like to think of this as our storage room. This is where we're going to be able to store all of our raw data that we're getting from the Rapid API itself, right? And so we talked about APIs briefly last week also. We've been using them throughout this entire challenge. But remember, APIs are essentially where data is stored that we are able to go and retrieve it at some later date, right? So when you think about Amazon S3 being a storage bucket, if you will, that stores things, let's go back to our kitchen example. So we have Docker as our portable kitchen, making sure that we have the same kitchen setup every time. And then for S3, that's where we're going to store those raw ingredients, right? Our flour, our sugar, any finished cakes after they are baked are going to go in this storage room, if you will. And each shelf is going to be labeled for easy organization. Now, I like to think of the shelves as the folders in our S3 bucket. So think about a Google Drive layout. You're able to have multiple folders within it that helps you get to, or data that is of interest to you. Okay, so next up we have AWS Media Convert. And I like to think about this as our professional cake decorator, right? So after we bake that plain cake using that Docker file, you want to send it to the decorator to kind of look a little more polished and fancy, right? That decorator could then apply like ice or decorations to meet those customer needs. Well, with MediaConvert, what we're going to be able to do is ensure that we are actually producing high quality videos. So if we wanted to set the resolution those images or those videos, what audio are required of that image, we are able to do so, right? So essentially, let's step into the files now that we've gotten an overview of kind of these services do. Okay, so I guess let's work our way from the ground up, starting with the Docker file, since that's going to build out the entire container for us. So as you can see, not really a ton of code here. Add in some comments so that way you can follow along. But taking it at a high level, step by step, first thing we're going to do is we are going to look at from Python 3.9 Slim. What this is doing is it's telling Docker to use a lightweight version of Python 3.9 as the base for the container. So let's bring it back to our kitchen example, right? This is like saying, let's start off with a basic kitchen that already has a stove, that already has a fridge. That's going to be considered our Python environment. And this is basically so we don't have to build these things ourselves. Next up, we're going to set the working directory of the container itself, right? It's setting that /app as that current working directory inside the container. So that way any commands or files will now be referenced to this relative directory. So thinking back to our kitchen that we're cleaning out, this is this kitchen that we're building out. This is like choosing a clean counter in your kitchen to start cooking. It ensures that everything is going to happen in one organized space. Now, next up, we have our copy requirements text. And what that's going to do is it's going to copy a text file that we've created called requirements.txt from our local machine to the container's working directory. And then it's going to run pip install. This is going to install all the Python libraries that we need in requirements.txt inside the container itself. So think about copying the things from requirement text file. It's like bringing a shopping list into the kitchen and then running pip installs, like buying all the ingredients listed in the shopping cart, right? So requirements text has 2 lines of things that we need, and then pip install is actually going to go and make sure that we get those things that we are interested in. Hopefully I'm not making you very hungry or losing you in the kitchen references. I just think that we all either know how to cook or have watched someone cook. So it's probably the most relatable example top of mind for me. I don't cook, so no shame to those who might be with this as strongly. But next up, we're going to copy .py, process1video.py, MediaConvert, process.py, and run all py. What this is going to do is it's going to copy all of our Python scripts into the container. So this is like placing your recipes or the Python scripts on the counter so you can follow them during the cooking process themselves. And on the tail end, we are going to run apt-get update and apt-get install /y AWS. And what this is going to do is install the AWS CLI inside the container. So that way we are allowed interaction with the services like S3 and MediaConvert. So in our baking example, I guess this would be like adding a new tool. Maybe if something required a blender to your kitchen, so that way you can perform tasks that your existing tools can't, because I think we only had like an oven and a fridge when we ran our first line of Python. And so yes, because we need to talk to some AWS services, we need a CLI to do so. And then last but not least, this is going to set the default command to run the pipeline, right? The entry point Python run all.py. This is going to set that run .py as the default command. Well, Python run all.py as the default command to execute when the container runs. This means that run all script, which automates running all the other scripts, is going to start automatically. So this is where we go next level. This is where we start to think about it from a sense of we are, guys, my cat back there is super nosy. But start to think about this like Tesla robots are accessible, right? And we now are programming our robot chef to start preparing the entire meal or all the scripts whenever we press the start button. So this probably would have been better to actually start with at the end, now that I think about it. But essentially, this Dockerfile is going to take all of those scripts that are out there and make sure that we build out that container with everything that we need. And then it goes and does it. So basically, we build our kitchen, we go shopping with our list, we have all of our ingredients, and we have our chef just whip everything up for us. Now, I know I said whip everything up for us. Let's look into the actual files themselves and talk about what they are doing. So let's take a look at fetch.py and all the things that it does. First off, at the top up here, we have the ability to import various libraries. At a high level, Boto 3 allows us to interact with the AWS services like S3. Request is going to be used for making those HTTP requests to the API itself. So essentially for us to go out and get the data. And then JSON handles the JSON data, so converting it into Python objects and vice versa. So not really a whole lot of interesting things going on there, but some things you need to pay attention in this block itself. At the top, we have some of our constant and API setups. So the first thing that we're going to do is our API URL. This is going to set up necessary headers, including the API key, to authenticate requests. Remember, whenever we're dealing with APIs, we need to be able to say, I have the ability to actually access this information, go and get it at this destination or at this endpoint. You will need to make sure that you replace your rapid API key within these brackets itself. I know, don't get confused with the carets. That needs to be removed also. The only thing that should be here are these double quotes at the beginning and the end. Bucket name, you can make that whatever you want. I mentioned in my previous video, typically just using some type of alias for yourself, 2 letters of your last, 3 letters of your last name, or something unique like that. So that way you'll always remember it. But that's where we are defining our bucket name. And then region, I recommend just using East US 1. It's the easiest to digest. I talked about like when you're actually building out production scale things, you'll want to put things relatively close to where they are being accessed to reduce latency. But our query parameters, Saint has lost her mind. I think she wants to teach you guys DevOps. I think I'm going to just let her stay. Hopefully she's not too distracting. Here we go. Be right back. Okay, about that. On to the query parameters though. Here, I wanted to call out and note that for this example, we are actually using the NC of the NBA, and that is because with Rapid API, NCAA is included in the free tier. For those of you who might not be based in the United States, the NCAA is our collegiate or our university level basketball team, and it actually has a lot of popularity here in the US. People watch university basketball just as commonly or just as often as they do the NBA. If you want to pay for the updated tier, feel free to do so. You'll just have to read through the API documentation and replace this. It is just NBA, but Then we're going to put a limit on how many highlights we fetch from this date. And that's just really for optimization. We're just trying to, proof of concept here. I don't want every single highlight. If that's something of interest to you, this is where you can come and tweak that number. And same with the date. Looking through the API documentation, I was able to find this date. If you have a specific date or moment you're interested in, feel free to swap that out here. Just make sure that you keep this format consistent so that way it can actually find things of interest to you. So moving into the part where we actually fetch our highlights themselves. What this is going to make an API request that's going to fetch those basketball highlights for us. Then it's going to convert that response from JSON format into a Python dictionary. And at the end of all of that, it's going to print out if it was successful or not. So that way, right within the Cloud Shell terminal window, we're able to see the status like that. And so this is pretty much like us calling up a sports agency and asking them, hey, send me the highlights from whatever date we had listed up there above. Moving into our next section where we save to S3. This is going to ensure first and foremost that the S3 bucket exists. And if it does not exist, it's going to create one. So it's going to go and look and say, hey, this bucket name doesn't exist. Let's create one. If it does exist, it's just going to say, hey, it already exists, and it's going to move on to the next thing. And it's going to save the JSON data or the highlights to the S3 under that specified path. So essentially, like, when we get this file back, it's not going to be an actual video. We're going to have to do some steps later to actually get something that's viewable. It's just going to be JSON data that essentially has like a URL to the video itself. So it would be like if you posted something on Instagram, I could physically see that video, right? If someone sent me the link to your video, I'm just going to have like the URL www.instagram.com/Alicia / whatever they put at the end of Instagram videos, right? And I'll show you guys that within the file itself. We're going to take that URL and do something with it a little bit later, but I won't get into that at this juncture. And then last but not least, we have process the highlights, right? So this is going to fetch those highlights using fetch highlights, and then it's going to save them to an S bucket itself. And in here, this is where we come up with the name basketball highlights. So it pretty much covers the fetch dot file itself. And so now that we had the ability to go out and get the data and save it in a S3 bucket, but it's just in JSON format, the next thing we need to do is we need to process one video. Whoa. Okay, so into our process one video.py file, the part largely the same as the fetch.py from a standpoint of we are importing the libraries that we need, and it's commented in there what each of them do. So for the sake of time, I will gloss through that. Same thing applies for our S3 bucket. We're going to replace that with the name that we used in fetch.py. Our input key is going to be our path to the JSON file in our S3 bucket. So this is basically going to say, hey, where does this existing file, basketball highlights.json, already exist? Remember, this is the file that has the video URL saved within it. Then our output key, this is going to be our path to where we actually want to save our video in the S3 bucket itself. So this is going to create a different folder called videos, and then we are going to save it as firstvideo.mp4. So this is an input, go and find. This is an output, go and place. And then the same thing, we have our region listed there. So for the download, and they have our region listed there. So for our process one video, what this is going to do is now we have these kind of constants defined. It's going to actually go and do it. So it's going to create an S3 client, and it's going to assume that IAM role, highlight processor role. This is something that we're going to set up in the prereqs of this document, but essentially we are going to create a role that has the ability to interact with S3, interact with MediaConvert, pretty much all of the that we are working with. so that way it can do tasks like upload and save and all of that good stuff. So this is the portion of code where we are going to retrieve that JSON file from the S3 bucket itself. This is going to extract the first video URL from the JSON data. The reason why I set this up in this manner is because that JSON file, I believe, was a mixture of videos and images. And so if you don't just run this and grab everything within it, you'll hit an error. And then also for the sake of time, right? Like we need to get one video and play it. We don't have time to be doing all that for the entire file, even though I think it said like 10. Of course, we could go back to this and edit it to where it could just find anything that is a video URL and excludes anything is not. But yeah, this was a cheap solution for us. This is going to then download the video from the URL itself. And then it's going to prepare the video to be uploaded to S3 to that output file that we have referenced down here. So this print, anywhere you see print, once again, that's happening in the Cloud Shell terminal itself. And this is kind of telling us what step or what part of the process is it actually on. If you wanted more in-depth like logging or debugging, you could use something like Cloud Watcher, which would tell you like throwback kind of logging as to what's going wrong and where the errors lie. But yes, this is showing it where to put the object. So we go and get that bucket name, we go and get the output key, and then this is going to pass the video data to the S3 client as the specified content type. So here we are passing it as a MP4. So that is how we just go and process one video. Okay, almost a home stretch. We are on the MediaConvert process.py file. Once again, up here, largely the same thing, import in our libraries. Also here we are setting our constants. Just some quick things to highlight. You replace your bucket name here. As we did in our previous examples, this MediaConvert endpoint, in the README, I'll have the actual bash script that you can run to get your MediaConvert endpoint and replace that information here. So that way this can run. Let's step into the create job function itself. And what this is going to do is it's going to initialize the MediaConvert client using our Boto 3. And then it's going to connect to a specified MediaConvert endpoint in the correct AWS region. So that's why we need that URL as listed above. Now within the job settings itself, a thing to call out here is that you're going to want to swap out your account ID in section. But what our job settings is doing, and it's a pretty lengthy chunk of code, so hard to get that in the full screen. But it's going to assume that IAM role for MediaConvert. It's going to assume that that MediaConvert has the proper permissions to actually go out and interact with the AWS service. Now, that's going to point to the input file of S3. So wherever we did the output in the last file, wherever we are storing that, this is now going to be our input for MediaConvert itself. We're going to specify that the output will be a file, and then it's going to specify the destination, which this process video will be saved in S itself. Now for the outputs, what does that need to look like? We're going to set up our video settings. So H_264 is going to use an 8.264 codec for video compression. And then bitrate is what's going to control the video quality. So the higher the bitrate is, the better our quality is going to be. And then our audio settings like AAC is going to specify the AAC codec for audio. And then bitrate and sample rate is going to control the audio quality. There are some additional settings down there at the bottom, like acceleration settings that's going to disable hardware acceleration. Is going to set the job priority to normal. So basically what this is going to do is it's going to go and grab that video, and we are going to now enhance the quality using AWS Convert. So cool stuff going there. So now we have in the media job, what they're going to do is it's going to send the job settings to MediaConvert to create the video processing job. And then it's going to print a response, which is going to contain the details about the job, like its status and its ID. We do have something in there for error handling. That way it can print if something happens. It's catch and log that error that occurs during the MediaConvert job creation process. And we specify our entry point down here at the bottom. So that way the script runs the create job when executed directly. So that is everything in a nutshell there. Last but not least, we have our runall.py, which is referenced in the doc file itself. And essentially what this runall.py does is it's going to go and run all of the 3 scripts we just talked about. There is some retry logic in there. And I built that in because if there are any errors creating a resource or finding a resource, sometimes it be because of like the time it takes to do so. So I wanted it to retry a few times before I actually just went kapoop and gave up on me. And then I also baked in some weight in there just in case things were moving a little slow, because all these scripts are dependent on one another. Think about it. We have an input and an output, so you can't go and file at a location if that file hasn't been placed there yet. That brings everything home. Let's go ahead and start stepping through the documentation itself and bring this thing to life. I'm going to operate under the assumption that you all have handled the prerequisites. You went to Rapid API and you've created an account. Like I said, we're going to be using NCAA actually for this example. Just some things you want to verify to make sure your environment is set up properly. And then you're going to want to find your account ID and your access keys, just in case, not just in case. So when you need them in this process, you'll have that information stored somewhere, kind of offside in the note. Now that you have went through and done the prereqs, let's go ahead and start off with step 1. Like we said, we're going to want to create an IAM role or a user who can go out and do all the things we're interested in doing and has the proper permissions. Remember, a big reason why we use these roles is so that things can go out and have just enough access to do what they need to do, not all the administrator level access that would have. If you go and work for a company, you're going to run into needing the proper permissions to do things depending on the level of your role and kind of have security set up. So up here at the top, we're going to come in and we're going to search for IAM, and we are going to create over roles. We're going to go and create a new role. Now for the use case, we're going to have to put in something to move forward. Well, let's just type in S3, but we're going to have to make sure we update our trust policy here in a second because we are going to need to interact with more than just S3 to make this happen. Now, I highly recommend from the README, you just copy and paste what you need. Depending on the size of your screen, as you can see, it's kind of hard to view everything. So that just makes it easier to search for exactly what you need. Sorry guys, I've been like sick, losing my voice for like a time now. And so sorry if it keeps going in and out. The 3 permissions that you need, and we're gonna go and click next. Now, under role details, we're gonna wanna make sure that we change the name to highlight processor role. And that is because that is specifically called and used within the scripts itself. Now, once again, we are building a Toyota right now, not a Ferrari. There are some things that you would want to do different at a production level approach for the sake of just trying to get our car going from point A to point B, not necessarily optimized to all the best industry standards. This is the easiest way to do this without you guys clicking around and doing a bunch of things that probably you'll find confusing. Okay, edit the trust policy, and you're going to want to copy and paste this bit of code there and update that. So now that we've got the proper policy set up, we want to come to a Cloud Shell terminal. Remember, this button right here opens the Cloud Shell. I'm doing it in a different window because it'll be easier here in a second. But we are going to want to copy this API. We don't need a location string for US East 1. So boom, we have AHL Rapids created. Let me move this out of the documentation so I don't forget it. So great. We can confirm that this bucket exists. If we do this, it should list all of my S3 buckets. Okay, great. Cooking with gas. The bucket is there. You can also do this within the UI itself. If you come up here and you search for S3, it will take you to your S3 services. And then we see, boom, our bucket is there. So great. Now it's time to go ahead and set up our project. Now I have already created a directory called Game Highlight Processor, but after you run this line of code, it will make a directory, and then CD simply changes you to this directory. If any of this sounds unfamiliar to you, just be sure to brush up on some of your Git terminology. CD is essentially saying, hey, after this directory is made, change us to this directory or change us to this folder. Now, if I hit ls, that just simply shows me all of the files that are already in this directory. Running this line of code, touch dockerfile fetch.py, all of these different file names is going to essentially create them for you, except for this IAM policy. I have that there for myself for another reason. So after you run this line of code, it will create the file. Now, one thing to note is that file is going to be blank. It's not going to have anything in it. It's just simply creating the file name. You're going to have to step through a series of lines where it says nano fetch.py. That is going to open up that blank file, and you're going to be able to go to the GitHub repository, and you're going to be able to add in the relevant scripts, right? So we're going to be able to go into GitHub and go to source and click on all of these files and update them. So you would copy and paste. I did put some notes in here where you need to swap out things like that S3 bucket that we created earlier or your rapid API key. Typically we would have this live in like an environment variable of some sort and call it for security. But for me personally, since this is just a very, very basic project, I wanted to keep it as simple for you all. I believe in some of the other labs, you guys will see how to set up environment variables and things like that. So I'm going to go ahead and skip to the part where we are dealing with this environment list. The environment variables we are going to create is there's a spot in our code where we're going to have to actually run this Docker file, and we're going to need some of our AWS credentials to do it. So the environment list file, what it actually does is it allows us to set our AWS access key, our AWS secrets key, and our default region in a file. So that way when we run that, instead of hard coding in that information in the Cloud Shell, it's going to pull it from this file specifically. After you create this environment.list and you save it, make sure that you secure it by running this line of code here. And what that actually will do is that will ensure that no unauthorized access to environment.list file is allowed. So it restricts the permissions. And then we're also going to want to add that to our .getignore to prevent it from being committed to version control. So you'll have a getignore file where you can just simply add that to the list itself. So once that is up and running and looking good, it is time to build this out. You guys can go ahead and pause the video and copy and paste all that information over. Like I said, I did place some reminders in there. There are some spots where your account ID needs to go in. Make sure all of that is updated. But we are going to first run this thing or build this thing, right? Because remember, if we come back to our image, the first step is we have our Docker file, which is step by step what we need to do. We need to build it into an image itself, right? So that is what we are currently doing. I'm going to go ahead and speed up the video once it finishes, so that way we don't have to sit here and watch paint and dry together. But roughly when it's your first time, it does take a couple of seconds to do everything and step through the process. That's finished. Now we're going to go ahead and run it, right? And this is how that image that we've built, we're now going to run it into a Docker container. Now, all of this is occurring locally. Docker works with all cloud providers, AWS, as well as Azure. And so you could build it on those platforms as well. So that way it's like repeatable and scalable. Like if you wanted to share it out with someone. Like I said, I wanted to keep this simple for you guys just to understand working with Docker itself. So of course you can use something like Azure Container Registry to build that within the AWS platform itself. I was able to fetch the highlights successfully and save it to the S3 bucket. As we could see, that S3 bucket already exists. So it didn't need to create one. I did forget in fetch.py we had the ability to create one if it didn't exist. So I guess we didn't have to run that bash script initially. but it's okay. I digress. So the highlights were saved to ALAHL Rapids highlights, basketball highlights. So let's go to our S3 bucket and go here. We got our highlights and we see basketball underscore JSON. Now I've downloaded this a trillion times, but let's open it together. When we open up our basketball highlights JSON file, remember what we said. This is only producing a URL for us, right? So it has some other information, right? It gives us a brief description of the game. So Arkansas Pine Bluff Golden Lions versus the Oklahoma Sooners. In the full light, I found at this URL. So as we can see, this is a video saved on ESPN itself. So we have a full URL, embedded URL, and this just happens over and over again for various clips. So this is a slam from Ismail Plet. That was too nice. That's a quick description. The processing part, right? So from the one video, we wanted to process the video URL. So this is the URL that it went out and got. And it uploaded the video to S3 underneath ALAHL Rapid Videos, first video MP4. So let's go back to our S3 bucket. And underneath the videos, we have first video MP4. Now, if we download this guy and open it, this should actually be, woo, this is cool. Look at this, guys. So this is actually now a video. So it went and grabbed that one video from the link, and now we're able to actually watch it. So this is stored in our S3 bucket now as a video. So we had a file stored at first. Now we have an actual MP4 video. Sweet, right? Now, what we noticed is there was some audio and quality that we didn't like about this MP4 that we have saved there. So the next thing that we need to do is successfully create that MediaConvert job that's going to go and update the audio quality and the resolution and the bitrate, right? There we go. All scripts have executed successfully. So now if we go to our last bucket, which is process videos, we see first MP4. Maybe I should change this. But if we open this one, it will be our, it'll highlight with increased audio or enhanced audio and visuals. Another thing you can do is you can go to AWS Elemental Media Convert, and then underneath of jobs, you'll see that we just ran this job at 8:15 a.m. It's 10:18 now because we went through a few different things. But right here, you see the inputs, right? So this is what we go and grab, that first MP4 from videos, and then we output this here with various details. So this has the duration and the resolution. And if we click on this output, it just takes us to the S3 bucket directly where we can view that video. So a lot of cool stuff there that all created in one wheelhouse to process all of our highlight videos and store them in S3. As promised, because I care about your security and hygiene, I will also create a delete script here that'll go and delete all of the resources that you were created in this file if you want to wipe yourself clean of that. And just like that, ladies and gentlemen, that concludes our day 9 of our game highlight processor. Check my link in the description for that video. If you guys got some value, go ahead and smash that like button. If you have any issues, concerns, feedback, things that you do to make it better, please be sure to leave that in the comments. I'm looking forward to some pull requests from you guys of, if you've done or files that you've created to enhance this project now that we have a good foundation built out. And last but not least, be sure to subscribe because we are only halfway through this challenge. And next week, we will be diving into some infrastructure and some automation. So let's get it.